Welcome to my presentation. This presentation is part of the playlist Integration by Substitution. In this presentation, we will be solving example problems related to integration by substitution. Let us look at an example. We want to evaluate this integral, 3x divided by square root of 4x squared plus 1 under the radical term dx. So we're going to use the integration by substitution to solve this example problem. Let us substitute u as equal to 4x squared plus 5. Okay, so since u is a function of x, we're going to differentiate u with respect to x. So du by dx is going to be equal to 8x. How is that? So d by dx of 4x squared is 4 times 2x, which is 8x. D by dx of 5, which is a constant, is 0. So therefore, du by dx of 4x squared plus 5 translates to 8x. So we can rewrite this as du is equal to 8x dx. So I brought this dx to the side of this 8x. So I can, if I want to express it in terms of dx, I can write it as 1 over 8x du. Now we can substitute u as equal to 4x squared plus 1 and then dx as equal to 1 over 8x du into the given example problem and then solve it using integration by substitution method. So our example problem is integral 3x divided by square root of 4x squared plus 25 dx, like that. So wherever we see 4x squared plus 25, we're going to substitute that 4x squared plus 5, 4x squared plus 5, this should be 5, 4x squared plus 5. We're going to substitute that by u. So 3x divided by square root of u times 1 over 8x du, 1 over 8x du. Okay, so now as you can see here, we have x in the numerator, x in the denominator. Those x terms cancel out. 1 over 8 is a constant, or 3 over 8 is a constant. So we're going to take 3 over 8 constant outside of the integral term. So 3 over 8 integral 1 over square root of u du. We can write it as follows. Then we need to convert the radical term into an exponential term to be able to apply the integration process. So we can write u, square root of u, as equal to u to the power of half, like that. So therefore, we can write this expression as 3 over 8 integral u to the power of minus 1 half du. So u to the power of square root of u I can write as u to the power of half. When we have a exponential term in the denominator, and then when we want to bring it to the numerator, the sign of the exponent changes. So when we have a positive exponent, when we bring it to the numerator, it becomes a negative exponent, like that. So 3 over 8 integral u to the power of 1 half minus 1 half du. So now we are ready to, we can apply the process of integration and then simplify it as follows. 3 over 8 u to the power of minus 1 half plus 1 divided by 1 half plus 1 plus c, where c is a constant of integration. So 3 over 8 u to the power of 1 half plus 1 translates to u to the power of plus 1 half. In the denominator, we have minus 1 half plus 1, which translates to plus 1 half plus c. So we can simplify it some more. 3 over 8 times, we have 1 half in the denominator. When we bring it to the side of the expression, it converts to 2 over 1 times u to the power of 1 half plus c. So we have a 2 in the numerator, 8 in the denominator. So we can simplify that. 2 times 1 is 2. 2 times 4 is 8. So we have this 3 times 2 divided by 8 times 1 translates to 3 over 4. So 6 divided by 8 translates to 3 over 4, u to the power of half plus c. But we know that u is equal to 4x squared plus 5. So wherever we see u, we're going to substitute x squared plus 5. Therefore, we can write this one as 3 over 4, 4x squared plus 5, the whole thing raised to the power of 1 half plus c. We also know that when we can convert the exponential term into radical terms, as shown here, 3 over 4 square root of 4x squared plus 5 plus c, where c is a constant of integration. So this is the way we are going to solve example problems which involve substitution, substitution, or this is how we're going to use integration by substitution. Let's look at another example. Let us say we want to integrate 4x minus 3, the whole thing raised to the power of 9 dx. So we're going to use the integration by substitution to solve this example problem. Let us substitute u as equal to 4x minus 3. Okay. So u is a function of x, so we're going to differentiate the function u with respect to x. So therefore du by dx is going to be equal to d by dx of 4x is 4, d by dx of minus 3 is 0, so we do not write that. So therefore du by dx is equal to 4. So du I can write as 4 times dx. So if I want to express it in terms of dx, I can write it as 1 over 4, not this one, this is incorrect, 1 over 4 du. Now we can substitute u as equal to 4x minus 3, and we can write dx as 1 over 4 du into the given example problem and solve it using integration by substitution. Our example problem reads as follows: 4x minus 3, the whole thing raised to the power of 9 dx. So wherever we see 4x minus 3, we're going to substitute by u as we mentioned here, and then we can therefore rewrite this as integral u to the power of 9 dx. We're going to write as 1 over 4 du, so that's what we wrote here, u to the power of 9 1 over 4 du. So since 1 over 4 is a constant, we're going to take it outside of the integration process. 1 over 4 integral u to the power of 9 du. Now we're going to use the integration process, the rules of integration, to solve this example problem. 1 over 4, which is a constant, u to the power of 9 plus 1 divided by 9 plus 1 plus c, where c is a constant of integration. So 1 over 4 u to the power of 10, 9 plus 1 is 10, divided by 9 plus 1 is 10 in the denominator, plus c. So 1 over, we have 4 times 10 is 40 times u to the power of 10 plus c. So now that we have simplified it as much as possible, we need to substitute u back as 4x minus 3. We cannot leave our solution as u. We need to express our solution in terms of x. So we need to substitute u as equal to 4x minus 3. So therefore we can write this expression as 1 over 40, 4x minus 3, the whole thing raised to the power of 10 plus c, right? So where c is a constant of integration. So this is the way we're going to solve these problems using integration by substitution. Okay. In my next video presentation, we will be solving more example problems related to integration by substitution.